into 10 raised to minus 11 Newton meter square per kilogram square. For finding out some problems, we need this value. We want to by heart this value. G is equal to 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. How these units come? To find out the unit of G, there will be an equation. F is equal to G m1 m2 by r square. So how these units come? We want to find out. How these units come. Okay. So cross multiplying this equation, we got F into r square equal G m1 into m2. We want to find out G. G is equal to F into r square by m1 into m2. That is unit. G is equal to F is force. R is the distance between two particles. M1 is the mass of the first particle and M2 is the mass of the second particle. Okay. F. What is the unit of force? That is Newton into. What is R? R is the distance between two particles and the unit of distance is meter, the internationally accepted unit. That is SI unit of distance is meter. So the unit of R is meter. Here R square, therefore meter square by m1 is the mass of the first particle. What is the unit of mass? Unit of mass is kilogram. So unit of m1 is kilogram into what is m2? M2 is the mass of second particle. Unit of mass is kilogram. So m2 is the unit of m2 is also kilogram. So G is equal to Newton meter square per kg into kg is kilogram square. This can be also written as G is equal to Newton meter square kilogram raised to minus 2. Per kilogram square is kilogram raised to minus 2. So this is why the units come. So this is gravitation, universal law of gravitation. Its mathematical expression, that is F is equal to G m1 m2 by r square and G and its value. Also, one more thing. If the distance is not r, if the distance is d, how will you write the equation? That we can practice. If there will be two particles, namely P and Q, the distance between them is d and the force of attraction is F, then how will you find F? The mass of P is m1, the mass of Q is m2. F is equal to G into m1 into m2, that's the product of the masses, by what is the distance here? D square. So in place of R, we use D. If the distance between them is x, how will you write? X square. If the mass is not m1, if the mass is x1 and here the mass is x2, how will you write? G x1 into x2 by r square. So from this, it is clear that we have to replace the correct variable in the equation. So whatever the variables are given in the question paper, we have to use the variable and find the equation. So here is the topic covered in the first section, that is gravitation, universal law of gravitation, its mathematical expression and the term G and its value. So we want to discuss another 4 topics in the next section. Okay, moving to the second section. Today we are going to discuss about what are the importance of universal law of gravitation, what is mean by free fall, what is mean by acceleration due to gravity, and what is the expression for acceleration due to gravity. In the previous section, we studied about what is mean by universal law of gravitation. As we all know that if there will be any two particle in the universe, there is a force of attraction between that two particle and that force of attraction is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Who put forward the theory? Sir Isaac Newton. According to that theory, and if we consider that theory has some importance in our daily life also. So what are the importance of universal law of gravitation? These are the some examples related to that universal law of gravitation, the importance of universal law of gravitation. The force that binds us to the earth. What is that force? Gravitational force. The gravitational force binds us to the earth. So according to the concept, as we all know that there is a force of attraction between any two particles in the universe. So if a human being X or Y or Z, if that particle, that means if that human being is considered as a particle, there is a force of attraction between that human being and earth also. That force of attraction is also called a gravitational force of attraction. That gravitational force of attraction binds us to the earth. That is the first peculiarity or the first importance of the universal law of gravitation. Second one is that motion of moon around the sun. Sorry, around the earth, not around the sun, the motion of the moon around the earth. There will be no explanation is needed, I think so, because you all know that the motion of the moon around the earth is according to the universal law of gravitation, or otherwise we can say that it is according to the gravitational force of attraction. Then motion of planet around sun. The motion of planet around sun is also regarded with the gravitational force of attraction. And finally, the tides, that is the high tides and low tides, is due to the sun and moon. Due to the sun and moon is also regarded with the gravitational force of attraction. These are some importance regarding gravitational force of attraction or universal law of gravitation. What are all the important? What all the importance are there? The first one is that the force that binds us to the earth, and the second one is that motion of the moon around the earth, and the third one is that the motion of the planet around the sun, and the final one, tides due to the sun and moon. All are the importance related to or regarding to the universal law of gravitation or gravitational force of attraction. Now we want to discuss about what is mean by free fall. What is mean by free fall? This is completed. Now we are going to discuss about free fall. Okay. If a particle is dropping from a particular height, the clue is that if a particle is not throwing, if a particle is dropping from a particular height, this is the particle, this particle is dropping from a particular height, the particle reaches the ground, this is the ground, this is at a height h,